Hello students, welcome back. How are you? I hope you're all fine, healthy, wealthy. Okay, now we are going to start this lecture on volume of a sphere. We have talked about the surface area of sphere, okay, and surface area of hemisphere. We also talked about the total and the curved surface area of hemisphere. Now it's time to talk about the volume of sphere and to do some questions based on it. I'm just going to revising the formulas of surface area of sphere and hemisphere, because when we're doing the question, here will be some of the formulas that will be bouncing back in our lecture. Okay, so starting with that, surface area. If you talk about the surface area of sphere, the surface area of sphere was 4 pi r square. Okay, the units were in some square units. Okay, here first surface area of sphere. I've told you the surface area and the curved surface area of sphere is same. All right, then we talked about hemisphere, and it's having two things here, having curved surface area and having total surface area. Here total surface area, curved surface area or surface area, all are same in the case of surface area of sphere. In this case, curved surface area is having some value and total surface area is having some different value. If we talk about curved surface area, this is simply just half the surface area of sphere, that is going to be 2 pi r square. It's having 2 pi r square, it's having 4 pi r square, so it's remaining with the 3 pi r square, and we are having it here, total surface area. These were the formulas we have studied in surface area section. Now talking about the volume of the sphere, in the previous lecture I have told you that the volume of a sphere is nothing but 4 by 3 pi r cube, 4 by 3 pi r cube, and the volume of hemisphere is just half the volume of sphere, that is 2 by 3 pi r cube, 2 by 3 pi r cube. Clear? Okay. So this was only about the volume formulas. Now we are going to solve some questions very quickly. So the first question of it is, find the amount of water displaced by a solid spherical ball of diameter. Let's suppose we are having any container. Okay, so here's a container and we are having some water in it. Okay, now you are just, you have lost your mind and you are just putting the cricket ball in this here. The moment you will be throwing it, okay, that ball will not be there, I know. Okay, this ball will be here. This level will increase and will be going something like from here to here. Okay, due to this volume will be covered by the ball, so the volume, the level of water will be rising up. Okay, so what volume will rise? Okay, what is it? This volume, simply the volume of the sphere, because it replaced it, na? So we have to find it, this exact amount of the space. Now this amount of space is volume. So basically we are going to find out the value of volume of sphere. This is spherical ball. You are given with two things, 1 and 2. These are the diameters. I have told you, whenever in these kind of questions we will be always using the radius in the formula, but if you are confused with this thing, given something diameter in the question, first convert it into radius. 14 centimeter will be the radius of it. Understood? Now the first one, amount of water displaced by a solid spherical ball. Okay, amount of water displaced by solid spherical ball, okay, will be equals to volume of spherical ball. Good enough. Now, volume of ball is equals to 4 by 3 pi r cube. Now, 4 by 3 is 4 by 3, pi is 22 by 7, and the r, which is the radius is given 14 centimeter. So, 14 multiplied by 14 multiplied by 14, is it so? Now, cut it 3 times. 14 square, okay. Here you will be getting 88, right? He will be getting 3. Here will be getting 14 square, which is 196 multiplied by 3. Okay. Divided by 3. So, this 3, is that so? No. Here's some good misunderstandings in our calculation. Okay. So, writing it again, it will be 4 by 3, 22 by 7, r, which is 14, 14 and 14. That will be cut by 2 times. Okay. So, here it will be 44 here. So, 44 multiplied by 4 will be 176. That is going to be 176. This and this. Now, multiply by 196 divided by this 3. So, you are going to have some value in decimal in the unit centimeter cube. You can just simply convert in liters too, but if you do not convert it in liters, it's okay though. Okay, so that will be your answer. Understood? Okay. And talking about the second one, this implies that radius will be equals to 0.21 by 2. Okay. Okay. That is going to be 105 or okay, what? It is meter, that will be in centimeters, or let it be in meters, whatever you want. Okay, that will be in, okay, let it be in the meters only. Okay, now again simple, the amount of water replaced by the solid spherical ball will be equals to the volume of the spherical ball. Now, the volume of the spherical ball will be 4 by 3 pi r cube. So, 4 by 3, 22 by 7. Now, r is 1.2, 1.05, 1.05, 1.05. Okay, that will be 7 ones are 7, 3, 35. Okay, and that is going to be 0.5. Now, 20, that is 2. 2 multiplied by 22 is 44. So, we have covered this and this. Multiply by 1.05 whole square. Okay, you will be solving it. That's going to be 1.05 multiplied by 1.05, 25, 5. Again, 5 to 5. That is going to be 1, 2, 3, 4, 1, 2, 3, 4. So, multiply by 4, 4. Okay, multiply by 44, 20, 10, 1. Okay, so here it's going to be again 0, 0, 1, 2, 1, 2. This is going to be okay. So 1, 2, 3, 4, 1, 2, 3, 4. That will be something 233.231 in what meters? Okay, I have just calculated roughly. This first step will be like that only. You'll just figure out whether the calculation is true or not. Okay, this is the method for it. Now, the next question, a dome of a building is in the form of a hemisphere. Dome of building in the form of hemisphere. We are going to have this hemisphere here. It will be having some radius r for sure. Okay. From inside it was whitewashed. From inside it is whitewashed. That means that is some hollow. Dome will be hollow only. Then it will be having some inside whitewashed of cost of rupees 498.96 is the cost of whitewashing. The washing is rupees 2 per square meter. Find the inside surface area of the dome. Now, inside surface area of the dome, talking about this radius is not given to us. So, we are assuming that this inner radius is r, okay, is equals to r, and cost of whitewashing is equals to cost per square meter multiply by cost per meter square multiply by the curved surface area of spherical dome. Now, curved surface area of dome is equals to 2 pi r square. Implies that 2 pi r square multiply by this curved surface area multiply by cost per meter square. Cost per meter square is given 2, okay, is equals to 498.2.96. That is going to be inside surface area. This is the inside surface area. This implies that 2 pi r square is equals to 498.96 divided by 2. I am just dividing it 2 times 481,648. So, this is going to be in meter square. Okay, in meter square will be equals to inside surface area. Okay, this is going to be inside surface area. Now, the second is volume of the air inside the dome. Now, the inside surface area of dome is equals to 246.48 meter square is equals to 2 pi r square. Okay. So, the first answer is here. Now, for the second one. The second one, it's asked that volume of the air inside the dome. The volume of the air inside the dome will be what? The volume will be the volume of the hemisphere. Okay. So, volume of air inside dome is equals to volume of hemisphere. Now volume of hemisphere equals to 2 by 3 pi r square, right? 2 by 3 pi r square, volume of pi r cube, sorry. Okay, that will be volume inside dome. For this, if even you will be putting value of 2 pi r square from here, will be remaining with the r, and you are not known to r. So if this is the first equation, so from 1, 2 multiplied by 22 by 7 multiplied by the r, okay, square equals to 246.48. Okay, or you can say that 44 and 7 here, this will be the r square. Okay, that means r will be equals to root it. Understood? So the value of r will be this. Now when you calculate it, the complete value will be 6.3 in meters. We are talking in meters, so r will be 6.3 meters. Okay, this implies that r equals to 6.3. This implies that volume of air inside the dome, this is the approximate values, student, is equals to 2 by 3 pi r cube, which is equals to 2 by 3, pi is 22 by 7, and r is 6.3, 6.3 and 6.3. Okay, 0.9 times, 0.3 times, 10, 100. That is going to be 44. 44 multiplied by 3 multiplied by 63 square divided by 1000. Okay. Now, the value of it here, 132 multiplied by 63 square by 1000. Now here you can calculate it, and that's going to be your volume of air inside the dome in meter cubes. The unit is important. So calculation part you can do it your own. Now students, this lecture is concise in these 3 questions. This is good for today. Now in the next lecture we will be talking about the new topic of it. Okay, so take good care of yourself, students. Bye bye.